What if you could break the one rule that governs everything? The ultimate cosmic speed limit. What if you could shatter the light speed barrier? Where would you go? What would you see? Imagine a journey of 2.5 million light-years to the heart of our closest galactic neighbor, Andromeda. Today, we're not just going to wonder, we're going to find out. We're about to embark on an impossible journey, a simulated voyage to the Andromeda galaxy. But we're not just sightseeing. Our destination is far more profound. We are traveling to a place where the very fabric of the universe unravels, where space and time itself break down. We're going to the supermassive black hole at Andromeda's core to simulate witnessing the end of reality. Because of the physics of our universe, this is also a one-way trip through time, a voyage into a future we can barely imagine. We will become a time capsule, the last witnesses to our own era of the cosmos. So get ready. Everything you've ever known is about to disappear behind you. Imagine a vessel, not of metal and wire, but of pure computation, a machine capable of simulating a journey so perfectly that it becomes real to us. This is our ship. It doesn't travel through space in the usual sense. Instead, it solves the universe, calculating our path and rendering our existence at each point, compressing millions of years into minutes. But this miracle has a cost. Our simulation must obey the laws of relativity. As we approach the speed of light, time dilation takes hold. For every second that passes for us, years, then centuries, then millennia will scream past for the universe we left behind. We're not just accelerating away from Earth, but from our own time. The story of this journey was dispatched moments before our final departure. It traveled for 2.5 million years to reach you. It is an echo from travelers who have long since completed their voyage. We are taking you with us. To understand the journey, you have to understand the ship. It isn't propelled by rockets. Think of it as a simulation engine. We aren't flying, we are recalculating our coordinates, moving from one point in space-time to another without traversing the distance between them. This is a thought experiment, the only way to cheat the tyranny of distance. The Andromeda galaxy is about 2.5 million light-years away. A single light-year is a staggering 9.5 trillion kilometers. To travel this distance with our fastest probes, like Voyager 1, would take not millions, but tens of trillions of years. For perspective, the universe itself is not even 14 billion years old. Even at a hypothetical 10% of the speed of light, the journey would take 25 million years. This distance was never meant to be crossed. But our simulated vessel will get us there in under an hour, achieving a simulated velocity of 99.99999999999999998% of the speed of light. At this speed, the universe outside will warp and distort, and time will break. For every minute that experiences for us, hundreds of thousands of years will flash by on Earth. We are sacrificing our entire timeline for one glimpse of the abyss. Let the journey begin. Our departure is silent. There's no roar of engines, no crushing G-forces, just a subtle hum, and then the world outside begins to change. We watch as Earth, the cradle of human history, shrinks with alarming speed. First a blue and white marble, then a bright star. Then it's gone, lost in the glare of the sun. We pass the moon, then Mars, a tiny red ember. Jupiter, a majestic swirling giant, fades into the starfield behind us. Saturn, with its ethereal rings, becomes a memory in seconds. We are now in the Kuiper Belt, a vast ring of icy bodies, the frozen remnants of our solar system's formation. Ahead lies the true frontier, the Oort cloud. This is the final outermost shell of our solar system, a theoretical sphere of trillions of icy objects, so vast it may stretch nearly a quarter of the way to the next star, Proxima Centauri. It is here that we take our last look back. The Sun is now just the brightest star in a sea of countless others. Our home galaxy, the Milky Way, reveals its magnificent structure, a vast swirling spiral of hundreds of billions of stars. It's beautiful. It's our home, and it's the last time we will ever see it like this. As we accelerate, time dilation takes full effect. The people we knew, the cities we lived in, the civilization that imagined this vessel, they are all aging at an incredible rate. Centuries, millennia are peeling away. By the time we reach the edge of the Milky Way, humanity's future on Earth, its triumphs and failures, will have already played out. We are ghosts, haunting a future we can never return to. We have left the Milky Way. Our home galaxy shrinks behind us, just one island of light in an ocean of absolute black. We've entered the intergalactic void, the space between galaxies. The scale here is an assault on the mind. The space we're now crossing is 2.5 million light-years wide. The average density is less than 1 atom per cubic meter. It is a silence and an emptiness so profound, it's almost sublime. The loneliness would be absolute, a solitude so complete it might be mistaken for the perspective of a god. From our viewport, the universe is a tapestry of entire galaxies. We are part of the local group, a cluster of dozens of galaxies bound by gravity. The two giants of this group are our Milky Way and our destination, Andromeda. The rest are dwarf galaxies, orbiting the two titans like moths around a flame. As we speed through the void, these ghostly ships drift by. Our focus is fixed forward, on a single, growing patch of light. It began as a faint smudge, but as we cross the immense distance, it grows, it resolves. This is M31, the Andromeda Galaxy. During this transit, the weight of our journey settles in. We have traveled hundreds of thousands of light years. On Earth, civilizations have risen and fallen. The continents themselves may have shifted. The human species may have evolved or vanished. We have no way of knowing. This is the pact we made, to trade our past, present, and future for one ultimate truth. The light ahead of us grows brighter. We are about to arrive. The transition from the void to Andromeda is a gradual, overwhelming dawn. What was a faint smudge now fills our entire view. We are inside its outer halo, a vast sphere of ancient stars, globular clusters, and dark matter. The scale of Andromeda is hard to comprehend. Our Milky Way is magnificent, but Andromeda is a true giant of the local group. Its stellar disk is significantly larger in diameter than our own, perhaps 150,000 to 220,000 light-years across. And while the Milky Way has 200 to 400 billion stars, estimates for Andromeda suggest it could be home to a staggering 1 trillion suns. For a long time, astronomers thought Andromeda was also far more massive than our Milky Way. However, recent studies suggest our home galaxy has a surprising amount of dark matter, and the two may be roughly equal in mass. It's less a monarchy and more a tale of two rival titans. We are now approaching the main disk of the galaxy. Andromeda is a beautiful spiral galaxy much like our own, with arms that appear more tightly wound. We plunge into one of these arms, and the view explodes into a riot of color and light. The sky is a rich tapestry of glowing gas and dust, lit by newborn stars. We see vast nebulae, stellar nurseries glowing brilliant red and pink. The density of stars is breathtaking. We are flying through a blizzard of light. Our course is set for the galactic center. As we travel inward, the star density increases exponentially. The light becomes almost blinding. We are approaching the galactic bulge, a massive swarm of predominantly older, yellower stars. And in the center of this blazing inferno,
We see it, a point of gravitational dominance so extreme that nothing can escape it. Hubble observations have shown that Andromeda's core has a strange, double nucleus. The leading theory suggests this isn't two black holes, but an eccentric, wobbly disk of stars orbiting the true center, creating the illusion of two bright peaks. It's a strange and beautiful dance around the abyss, but our true destination lies at the center of that dance. This journey to the heart of Andromeda is a journey into the fundamental nature of our universe. We are pushing the boundaries of what is known. If you believe that the pursuit of knowledge and the exploration of the cosmos are among the most important things we can do, then join us, subscribe to this channel, and become part of our crew as we continue to explore the deepest corners of reality. Your support allows us to keep